Unnoticed by end user, Linde technology facilitates refueling of fuel cell electric vehicles. From the customer's perspective, the procedure will resemble that of conventional vehicle refueling. Just bring the refueling nozzle in position on the car and press start. Now behind the scenes, the individual modules of the hydrogen fueling station are starting their operation. Let's start with the hydrogen supply. For the on-site storage of hydrogen, there are several possibilities. In the example, you see a liquid tank, gas tank, or medium pressure storage unit. Hydrogen is taken from the available supply and compressed and temporarily stored in high-pressure storage systems. The main modules of the compressor station are the ionic compressor together with the downstream separators, as well as the high-pressure storage banks and finally the cooling unit. All the modules are housed in a 14-foot container. So how does the ionic compressor actually work? For hydrogen fueling stations, Linde has developed a 5-stage ionic compressor. The pistons of the machine move up and down hydraulically. On the top of the pistons, there is the ionic liquid, which is compressed through the compressor cylinder as a liquid piston, together with the hydrogen. At the end of the compression process, the ionic liquid is separated from the hydrogen by the separators and returned to circulation. This design results in less wear and tear, as well as much higher energy efficiency, thanks to optimized cooling and avoidance of parasitic volume during the compression process. Compared to a conventional piston compressor, energy savings are around 40%. Following the compression from a minimum of 5 bar inlet pressure to a maximum of 1000 bar outlet pressure, the hydrogen is temporarily stored in the high-pressure vessels. For Europe and the United States, Linde uses storage tubes made of steel which are wrapped with carbon fiber. You can integrate up to 1300 liters of storage volume in a container. In some countries, pure steel cylinders are used instead due to the specific regulatory frameworks. Once the vehicle fueling process is started, the hydrogen flows from the high-pressure storage through the Linde-developed aluminium cold-fill heat exchanger. It is directly cooled to about -40 degrees Celsius. The aluminium cold-fill heat exchanger, in contrast to conventional liquid cold-fill units, is maintenance-free and can be cooled to even lower temperatures if necessary. Cooling the hydrogen is necessary to enable refueling in less than 3 minutes. After a successful pressure pulse, with which pressure tightness and fueling parameters are checked, the actual refueling process begins. The hydrogen now flows through the dispenser lines towards the dispenser. Safety-relevant parameters are constantly monitored before and during the refueling process. As soon as the vehicle tank is full, or if a user presses the stop button, the fueling ends. After approximately 3 minutes of fueling, all that is left is to disconnect the nozzle from the vehicle and enjoy the ride.